class to figure out how to do it right, and you should have corrected and finished attempting. So when I pick up your homework spirals on test days, quick reminder as we're starting off the semester, I'm seeing, did you finish attempting by the test day? I give you tons of grace on this. Did you finish the homework, number 1? Did you grade it, number 2? And if you got something wrong, did you figure out how to do it right, number 3? If you did all those things, 100%, every single homework spiral check. Does that make sense? Okay, if you ever have any questions, let me know. Because I don't want you guys getting anything other than 100%, and yet time and time again, you guys are missing points the day of the test because your homework spiral, your homework wasn't fully done, graded, corrected by the time of the test. We're on 1 through 6. We're moving down, but first, Priscilla, you had a question, yeah? What's up? It's not bad to have thetas, but depending on what you've been given, you should make it match. So like on the formula quiz, if I have something like tangent of x equals, for quotient properties, you should put sine of x, cosine of x, and make it match. Does that make sense? Yeah. So in this one, I'm guessing the original problem was u's, so you would just want to make it match with u's. Okay, number 32. Did you guys get all the way down to... Now, some of you automatically are going to start saying, ugh, I'm wrong. But hold on. There are actually 3 different ways of writing this answer. And maybe you figured it out, and maybe you didn't. There are 3 different ways of writing this answer. You could have written this one, or you would have been just as right if you had written negative cosine of x minus 1 times cosine of x minus 4, or cosine of x plus 1 times negative cosine of x plus 4. That one's right, and that one's right. So if you have one of those, you're okay. But just because there are 3 different ways of writing it doesn't mean it was easy. Can anyone say or tell me why this factoring problem was a little bit harder? Yeah, I don't like the negative in front. I don't know about you guys. Like, you don't like numbers in front, we all know that. But negatives in front get confusing too. And so even though you could have left it in and gotten factors, I think, to be honest, I'm with the answer key on this one, that the first step, just to make life easier on yourselves, would have been to say, ugh, let's pull them out. Factoring out would have gotten the inside trinomial to be a lot easier. And then, hopefully, with a simple little x method, if you pulled the negative out, you could have gotten the negative 4 and the negative 3 to go ahead and get, what, negative 4 and 1? Once you pull that negative out, life got a lot easier. Tyler? And the reason is, remember with multiplication, 2 times 3 is 3 times 2. Multiplication is... Oh, like you might have switched those? That's actually okay, because check it. It's the same thing as this one. Yeah. So you could have had 4 minus cosine of x, either times cosine of x plus 1 or 1 plus cosine x. That would be okay. Yeah. Okay. 48. The book makes a huge jump for some of you. For some of you, you're like, oh yeah, I got it. But for others of us, do you guys see the huge jump for some of you? Right here. The very first step. For some of you, that's a huge jump. For others of you, it's not. But for those of you for whom this is a huge jump, what work should you have shown in between these two? How'd they get from there to there? Common denominators. This guy would have had times a cosine over a cosine. This guy would have had, 1 plus sine over 1 plus sine. And so in between here and here, they actually multiply. Cosine times cosine is cosine squared. They noticed there was a common denominator, which would have been that cosine of x And then they said, oh, 1 plus sine times 1 plus sine is 1 plus sine squared. But to be honest, I wouldn't have even written that. You know why? What could you possibly kill if you write it like that? Ah, close. Seal is the negative. Puppy. Yeah. I would have written it this way, because right here you can say, well, I bet I'm supposed to do something up here, so let's FOIL. 1 plus sine. I would have just kept it just like that, because then I wouldn't have made the silly mistake of squaring. Now, we could go back to their answer key, but they already kind of started writing it weird. What would you guys have done from here? Or what did you do if you got that far? Wait, even though they're like so far apart from each other? Can you rearrange addition like multiplication? Uh-huh. So what can we say about cosine squared of x plus sine squared of x equals 1? What's 1 plus 1? 2. What's 1 sine of x plus 1 sine of x? So your numerator ends up being, oh, careful, not squared. It's a really common mistake. 1 sine plus sine is 2 sine. Yeah, just sine. No multiplication. 1 is 2. Did anybody stop there? If you stopped there, you still did a great job. But, well, you can't really add them, but what you can do is say, hey, there's a 2 in both. Why would we have factored them? Yeah, look at that 1 plus sine on top and on bottom. Anybody see the final answer should be 2 secant of theta? Sorry, of x. My bad. Priscilla almost did what you said. Get the variable and just keep using it. Because 2 over cosine is 2 times 1 over cosine. Let's go back to the answer key and see if we match up. They started showing their work pretty well after that. Just this was the step where they got a little funky. Took a bit of a jump. But it's hard sometimes in the answer key. They're not going to have a little like geometry proof where they put a little explanation as to what they did. So some of you are going to think this looks magical, but really sine squared of x plus sine squared of x is 1, and 1 plus 1 is 2. There's a fly on the board. Fly. I don't know what. Simplify 2 over cosine is the same thing as 2 times 1 over cosine like we saw yesterday, so 2 secant. Who got there before we did together? Wow. Nicely done. Wait, that was it? No more evens? Doesn't mean you got it all. Is there anything on the odds you got stuck on? Like you saw where you were supposed to get? 55? 51? Oh yeah, lots of 51s. Any other ones? Okay, let's go 51. Wait, chapter, am I in the right section? Is that 51? Oh, yeah. What was weird with 51? Some of you might have had your calculators at home, and some of you might not have had your calculators at home. Let me take attendance real fast. Jason's gone. The rest of you guys are here. True. Yeah. Okay. If you ever forget your calculator, like at school or something like that, or it's out of batteries, how can you graph if they ever ask you to when you're at home and don't have a calculator? You could plot points. You could do Desmos. That would be a good one. There's also one that's called Wolfram Alpha. And maybe you've heard of that one, maybe you haven't. I'll show you kind of the pros and cons of both. There are also, like if you look up online graphing calculators, but has anybody tried that? And they're kind of actually hard to use. Yeah, if you have a non-iPhone, any Android device in there, oh, what's it called? Is it the Google Store or whatever it is? With their apps, there actually is a really great but illegal TI graphing calculator that has like the entire TI. You just hit the buttons. You can look at Thomas Hurst's phone. He has it. But the Apple Store would never allow that to be an app because it would need to come from TI or else it's illegal, and there's not quite the open market. Anyway, long story short, if you have a non-iPhone, there's a really great app that's a whole graphing calculator. But otherwise, you have to kind of be legal, and it gets kind of messy. So I would probably say Desmos is the easiest one, especially if you're on a device as far as graphing. So we're going to peek at him. If you guys notice, online graphing calculator Desmos does come up first, but as soon as you start hitting other things, I don't know, all the ones that I've seen I just don't like because they're weird and like doing them is weird. It basically looks like Desmos anyway. But if we were to go ahead and put in the function, why am I saying this? Well, the one you guys asked about, the directions actually say use a grapher to figure out what's going on. So you don't even necessarily have to play with it, even though you could have played with it like the rest of homework. You could have just graphed it. We have cosine cotangent times cosine of x times cotangent of x. Is it plus sign? Yeah. What doesn't it like? Oh, then it comes up with these error messages. Use parentheses around the argument. Oh. Okay. I guess your grapher, doesn't the TI need the parentheses too, like it does it itself? Who is this guy? They think we should know. Wait a minute, it's a bouncity bounce bounce. Hold on, which one's bouncity bounce bounce? Secant and cosecant off of sine and cosine. So who is this bouncing off of? Is it bouncing off of cosine? Or is it bouncing off of sine? Yeah. So who bounces off of sine? Cosecant. So just from the graph and seeing how the bouncity bounce bounce is off of a sine curve instead of a cosine curve, that wouldn't work. It would. These would be in different places. You could have gotten cosecant, but let's say you didn't even, I don't know. You didn't figure out the grapher, you didn't have it at home, you didn't know what to do. You could have actually cheated just a little bit on this one. We can go here. And when you're given the problem, done what you did the rest of homework, did anybody actually just do it algebraically? And realize that cotangent could have been cosine over sine? They didn't mean for you to do it this way, but you could have. Couldn't you have gotten a common denominator like we did in class? And multiply by sine over sine? Couldn't you have gotten cosine squared plus sine squared? Both of x all over sine? What does this end up simplifying to be? And who is 1 over sine? So either way you end up with cosecant. You could have kind of cheated. Maybe for some of you that would have been faster than even finding your calculator or trying to do Desmos. Maybe some of you would have gotten the picture or did get the picture and you just didn't realize what it was. Wolfram Alpha is kind of fun too, but it can do a whole lot more than just graphing. Like for instance, you could say something like factor and then do some nasty polynomial by doing like x to the 4th minus 3x to the cubed. Now they did kind of figure out that this sort of thing can actually make money, and so I think you can only do so many of these like a day for free without paying for it. But it is kind of cool in that they can factor stuff for you, they can solve stuff for you, they can actually do crazy calculus things like derive and integrate stuff for you. It's a really cool website, Wolfram Alpha. They could find graphs also, but for Desmos, or for graphing, I think he's probably the easiest one as far as getting a quick graph of. And you can do fun things like just tap on it to get like minimums and maximums, or if it did cross to find the zeros, which is super nice. All right, anyway, wanted to show that to you guys just in case that ever helps. Let me go ahead and leave him, and let's get back to homework. You guys asked about 51, but also 55. Hey, is this similar to the one I had you highlight in your notes yesterday? Mm-hmm. It should be so easy, because all you're doing is what? Plugging in. But what else do you have to do? Starts with an S and ends with an amplify, which involves some of the stuff that you guys are saying with square rooting. The problem is so many puppies die. Well, more than just puppies, but puppies are usually the most common losses. But hold on, let's just make sure you plugged in right. What happens when you plug in? What did you guys write? That's where the danger comes in. Some of you literally wrote 2 secant squared of theta. Why is that bad? The 2 didn't get squared. So then Joe said it correctly. If you understand what's going on, 2 secant of theta squared, what does he mean? Parentheses. Yeah. Without the parentheses, you're in big trouble, because without the parentheses, you'll forget that this actually should be a 4 secant squared. And if you don't have the 4 secant squared, well, first of all, you won't know how to square root of 2, and second of all, you'll kind of make 2 mistakes. Now there's a dilemma, though. Do I say the answer is 2 secant minus 2? It's totally illegal. So what do? Pull out the 4. If you're following what we did in notes, pull out the 4. And if you pull out the 4, I can square root him, but I still can't, totally illegal. I can't go across that minus. If only there was something to make this one expression instead of 2. If you look at your Pythagoreans, rearrange secant squared minus 1 is... All life is good, because I can square root the 4. I can square root the tangent squared. If you want to be snazzy, you put absolute values because of that whole property from a long time ago that technically must be followed. Dun, 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 dun. Does that kind of make sense? Pause. If you got it wrong, make a note to yourself about the mistake that you made. Be like, don't forget the parentheses. Don't forget to factor. Don't take the square root across a minus. Illegal, illegal, illegal. Make yourself some sort of note. Everything okay? Ants in America aren't near as bad as ants in Africa. Hang in there. Did you get it? Oh, is it the little bug that was on the screen a second ago? Those little bugs. All right. Double checking real quick. 51, 55. Anything else? Going once? Going twice? You ready to have some fun? Section 5.2. Let's go. Section 5.2. It doesn't look fun because there's words, but just wait. The puzzles are coming. Woke you up. Podium's waiting if you need it. Section 5.2. Yesterday, I barely introduced the idea of a T-proof. So we're going to go ahead and make sure that we understand the intricacies, the details necessary. Then we're just going to play today. We're just going to play tomorrow. This homework that I'm changing up here, back here on the board, which I think it's homework 33, right? I was a little bit off yesterday. We'll not be due until Monday because you guys need some time and we need to do as many examples as possible, and a lot of you should probably have an honors pre-cal kid on call to be like, hey, if I get stuck, can I reach out? Because I already told you guys there's going to be a quiz after section 5.2 on 5.1 and 5.2. And for some of you, it's going to be the most frustrating thing on earth because you know what the answer should be. And so you're not going to give up until you get it, and you're going to get stuck. This homework is going to be frustrating at times. It's going to be really nice at times. You're going to feel really affirmed and be like, haha, I got it, and I know I got it. And maybe you did. Maybe you did something illegal. But there are going to be times when you're like, because you will see what it should look like. You will see what it should become. And how to get there is the point. Let me go ahead and zoom in on the words. Unlike other math homeworks, which actually makes it super practical and applicable to so many different fields, unlike other math homeworks, the point is not getting the answer in this one. They're going to give you the answer. They're going to give you the fact, the statement, the identity that is always true. The point is not knowing the truth, not knowing the beginning and the end, but the path that you must take to get there. It's all about the proof, which is why I related it to geometry. Let me highlight some important words, okay? Some of you might want to write every single thing. Some of you might just want to write the highlights. And so let me go ahead and highlight what I think is most important. How. This is the how-to. How to do T-proofs, how to verify identities. One side at a time. One side at a time. Usually choosing the more complicated. Yesterday, when I was showing you that example, let me do a different color than black. Yesterday, I was saying this is similar to choose the given. If you want to put a little note, choose the given. You have to choose one side to make the given. The other side is proof. And just like geometry, you have to start from the given and go to the proof, figuring out the steps in between. You're not allowed to go back and forth, bounce around. Use the proof any other time besides the very end. Doesn't mean you can't look at it. Doesn't mean you can't strategize based on it. But you have to go from the given to the proof. It's a proper way of showing the path, of showing the why, of properly verifying. So choose the given. Work with one side. And usually you want to choose the more complicated side. Next step. If you guys notice, each of the words I'm about to highlight were actually directions in section 5.1. Look to factor, look to add, look to square, look to, I'll go ahead and highlight that one, but let me try to simplify it. Look to, I would say, apply, 5.1 made you, forced you, told you to do these different things. So I bet you're going to have to use it in 5.2. Can you factor? Is there a GCF? Is there a trinomial? Is there a difference of squares? Can you factor? Do you have fractions and you need to go ahead and add them? But to add fractions, doesn't that mean you need a common denominator? They didn't actually say it in so many words, but they kind of gave the scenario when you need it. Could you factor? Could you do a common denominator? Could you multiply stuff out? Could you create a monomial denominator? We'll have to see that one in practice, kind of. But could you make denominators and then with fractions then get common denominators? So number 2 is like apply the 5.1 skills. Number 3, identities. And you guys were doing that in 5.1, weren't you? Going back and forth to the formulas and trying to see if anything helped. Look to use the identities. And then try to pair up. I actually really like this one too. Look to use the identities. I'm going to put consider. Consider the proof. And that's just using the geometry formulas, the geometry notation or the geometry vocabulary. You're working with the given, but keep looking at the proof and ask yourself, which functions are there? Are there sines and cosines? Well, let's go to sines and cosines if you transform with identities. Are there secants and tangents? Well, let's go to that. There are things that pair up. Sines and cosines pair up. Didn't mean to do that. Sines and cosines pair up. Secants and tangents pair up. Cosecants and cotangents pair up. So look to the proof. Consider the proof. What's there and how are you going to get there? Here's a quick warning though. Just because you don't know exactly how to get there doesn't give you an excuse not to try. This is a homework where you're not going to necessarily know exactly every single time how it's going to work out, but that doesn't or shouldn't paralyze you and stop you from trying. Number 4 is kind of like a fail-safe. It's like, well, if nothing else is working, if the preceding guidelines, if numbers 1, 2, and 3, if choosing the given and just starting with it, if looking for the 5-1 skills, all the mathy stuff, if looking to the identities, back and forth to the prove and whether the identities would help, if none of those are seeming to help, well, worst comes to worst. The advice is try converting, change everything to sines and cosines. Look to the reciprocals, look to the quotient properties, get everything, all the tangents, all the cotangents, all the cosecants, all the secants. Just change everybody to sines and cosines and maybe something will work. But that's only after you've already tried 1, 2, and 3. Go to sines and cosines. Forget trying to keep in the other guys. Just change everybody to sines and cosines or in terms of sines and cosines. And here's the hardest piece of advice. Why does number 5 kind of suck as far as a piece of advice? It basically says don't give up. It's saying that some of them will be hard. Saying that you get to the end. You sit down and start pouting about it. Or you turn around and go try some other way, right? You have choices. If you see a dead end or something that looks like a dead end, you can just have a pity party. Or sometimes you might want to have a pity party. Go get a snack. Go get a drink. Go watch like a meme for, put a timer. Careful if you go on YouTube. Or on Insta. Or on anywhere else. Maybe you need to kind of detach for a second. What would you say? Go to Starbucks? Go somewhere. Maybe Coffee Bean. Go pop a chocolate. But otherwise, you can have a little baby pity party, but don't just stop. Even failing can say or can teach you something. Always try something. Now, that might totally depress you, except this one that we did yesterday, wasn't this kind of an easy one? I mean, maybe it wasn't for you, but does it make sense? I mean, it was 3 steps, and one of the steps was just saying, hey, I got it. And one of the steps was saying, hey, I know where to start. There was really only one step. So not all of these are going to be crazy hard, but there are going to be ones that are discouraging. Before we totally go to more examples, you might want to just peek at this and see if there's anything that you need. The first one basically is saying the same thing as choose the more complicated side. Choose the one that you can do more math to. If one of the sides says equals 1, I don't know what to do with 1. 1 can come from a million different places, actually more. So if you choose the more complicated side, that's basically something that we already wrote. But it says more useful algebra. So if there's a side you can do some algebra, you choose that one. This one says you can't assume the 2 sides are equal, so look to the prove, but don't. You have to end at the prove. You can't use it somewhere in between, or you can't jump from one side to the other side, or you can't work back and forth. Here's the sad thing. One quick application of this is you can't square or square root both sides, because as soon as you try to do an algebraic something, you're using both sides. You're not allowed to use both sides. You only have to stick with, or you have to stick with only one. So the whole like adding to the other side, dividing to the other side, no, it's illegal. That's putting your given and prove all together. You have to keep them separate. Start from the given, work to the prove. And then the third one is just saying, look back to 5-1. Those directions, factoring, using a common denominator. But As you notice, some of these were kind of in the ones before, and I kind of already wrote them in for you. So the big thing from this page is you can't go back and forth. You can't do anything to both sides. So what you're used to with algebra is kind of illegal. You have to start with the given, work with the proof. A couple more seconds, just in case you're writing down something. But otherwise, I need to show you guys something. Let me freeze the screen. I'm going to pick up, well, how can I show this to you? CalcChat. What's CalcChat? How do we use it? How do you use it? How should you use it? Let's just say that. How should you use CalcChat? When you're stuck, to go look at some solutions, right? Okay. So what if you get stuck in section 5.2? I'm going to show you something, because didn't I tell you every now and then that CalcChat doesn't do things the same way that I do? Okay. Here's a problem with CalcChat. Here's something kind of similar to one of the ones that, or the one that we did yesterday on CalcChat. What don't you see? This is a solution from CalcChat. What don't you see? Look at my proof and look at this proof. Super similar. Well, let's just go to 15. It's an odd. Look at theirs. Look at mine. There's no T. Guess what I'm going to be super frustrated at if I see in all your homework, because I'll give you a 0 for the homework check. If you don't do T's, what do I know you're doing? Following the book. Now maybe you're thinking, but the problem is, have you listened to me at all? I want you to do a T proof. Now, pause. Can this still show you the steps? Yeah. But you need to organize it with a T. Why? Because in geometry, organizing proofs was very important. Same thing with me. I don't want you to get confused, and so a T is what I think we need to do. So I'm telling you to do it, okay? Okay. Let's go do some examples. Let's go do some examples. One of these is going to be your given. One of these is going to be your proof. You get to choose which one's which. That's what's different from geometry. One of these is a given. One of these is a proof. You get to choose which is which. But part of the choosing is figuring out if one of these is better as a given and the other one is better as a proof. Sometimes it's just your brain being like, I think I could do something to that. Sometimes it's you just looking and saying, that side looks a lot harder. Be careful. If you don't organize it the way I want on a quiz or a test, I will take off points, which means if you organize it properly and have no clue, you'll at least get a little something, something. So how do we organize it? We draw a T. How else do we organize it? You show me which one is going to be your given. So I don't know. I mean, I do know, but I don't know what you guys are thinking. What would you think is a good given, the left or the right? Okay. Joe used the left, but I'm hearing a lot of rights. Okay, let's try the right. If Joe used the left, he's pretty sure it works, but let's try the right and see if you could do this one. If you choose that one as the given, totally valid, you're allowed to choose the right. Why did you guys say that? What were you seeing? 1 minus sine squared equals what? Cosine squared. The Pythagorean property. Now pause. Rewriting it is you showing me this is my given. If you don't rewrite it, I'll have to take off a little bit. But now what? Well, I guess it is easy, but it doesn't match, right? So now what? Take out a cosine? 1 over sine is cosecant. Can I show you what would have happened if we had chosen the left? So far what Tyler saw is that this could be the same thing as cosine squared times 1 over sine, which could be cosine squared times cosecant. But are we getting there? What if we had chosen the left? Why would we have chosen the left? Are these harder trig? I think so. Joe might not, but I think they're harder trig in a sense that there's more that can be plugged in for them. What do I mean by that? I see sines over here, and I see stuff that no sines yet. But what could I do to cotangent and cosecant? Make cotangent squared. Pythagorean, cosecant. That's another good one. But we could use that trick of changing the sines and cosines, seeing that there are no cotangents or tangents or cosecants or secants. Cosecant is 1 over sine. When we divide something by a fraction, how are we doing? We're doing great. Because doesn't a sine and a sine squared? Looked at our proof. Maybe we should look at our proof. But look at all these things that we were able to do without even looking at the proof. Now look and say, wait. Cosine squared is 1 minus sine squared of t. You show me that you got there by rewriting it and saying, look, it's my proof. That's the last step to the organizational part. Look, it's my proof. And one way of showing that is with a check mark. One way is saying what, or putting what Joe just said, QED, quod error demonstratum, thus it has been proven. Either way, you're saying, haha, I got it. But could we have gotten there from here? Yeah, but it would have been a little bit hard. Because what you would have wanted to do would have been kind of crazy and seemed really magical. Because multiplying by 1 over doesn't really seem to make any sense. It comes out of nowhere unless you know that cotangent squared is cosine squared over sine squared. And if you bring this in, you actually could have gotten there pretty quickly, but this step looks awfully magical if you don't know where it is you're going and who they are. That could have become cotangent squared. That could have been 1 over sine, which is cosecant. But you would have kind of had to pull something out of the hat. You guys know what I mean? Like a magician with a bunny out of the hat. It's like there's nothing there. Oh, there is? There's nothing there. Oh, there could be? I think this side is a lot harder. I think that side is a lot more straightforward in getting to use identities. Lauren, you said wait, sorry. Did one of these not make sense over here? Okay. Okay. Joe.
Can't we just say cosine squared of t over sine of t cosine of t times cosine squared of t over sine?
No. Because cosine times cosine squared is cosine cubed. You can't just put a cosine. You can make this cosine times cosine, which would be 1 cotangent times 1 cosecant and match that. Does that make sense? You could do cosine, cosine. Sorry, cotangent times cosine, which and the to get to match. Well, remember how in 5.1 we could make it look like all sorts of different things? This is just one option of what it could be. There are other ways of changing it too. So your cosine times cotangent could have been the other side. Does that make sense? So we could transform, I think like transformers, they can change to be all sorts of different shapes and sizes, and some make sense and some don't. You can, like a piece of Play-Doh, you can make it look like all sorts of different stuff. But this one's saying make it look like that specifically. So we're trying to find the right steps to make it match what they told us to make it match. As we go over, let's go ahead and try another one. Simplifying complex fractions. There we go. How about this one? Fractions are going to come up, so we might just do some basic fraction practice just to kind of get us less scared of them when they show up with trig. I don't want to do that one. Maybe I don't want to do that one. Sorry, can we switch? Lo siento, you all started writing it. I want us to practice fractions at the beginning of class tomorrow, so let's not do, the other one needed some fraction work. Let's go to this one instead. Does this look kind of like one of the 5.1 types of problems? I think so. The left-hand side does, right? So what do you guys think I'm going to choose as my given? Yeah. It's harder. There's tons of stuff going on. And from section 5.1, is directions or what we needed to do when working with common denominators. Why don't you guys see how far you can go? Feel totally free to reach out to your groups. But get common denominators. That's a great way to do this one. It just didn't match. How? Okay. So keep going. You just weren't done. I thought you were saying stop. No, keep going. Yeah, there are many different ways of getting there, Joe, as long as it's legal. But yeah, you're right. You can keep going that way. See how you and I both had to multiply by something extra? That's hard for a lot of people. How you guys doing on your common denominators? Do you remember from last night's homework what happens when you have sine squared plus cosine squared? I can make it 1. No negatives, I don't think. What's 1 plus 1? 2. Oh, this is the one we went over, didn't we? 1 plus 1 is 2. What can we do with the 2? Pull it out. And then, Tyler, you were the one I think said earlier, like, oh, when you pull it out, what can we do with the top and the bottom? Yeah. The crazy thing is, the skills from 5.1 is what makes this problem from 5.2, hopefully, 2 over cosine is 2 secant. Not that bad. When does it feel good? When you can make a match. When is it going to feel really crappy? when you know what it's supposed to look like and you can't get there. So what are we doing tomorrow? Examples, 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 so that you can pull on things when doing your homework. But what should you do tonight? Start with the T's. Bye, guys. Catch you later. Catch you later. Alligators.